Hi everyone, today we'll be discussing the LeetCode problem of the day, minimum score triangulation of polygon. In this problem, you are given a convex n-sided polygon where each of the vertex has an integer value assigned, and you can get the value from this integer array values where the values of I denotes the ith vertex value in clockwise order. Suppose we have a polygon like this. So we have 1, 2, 3, 4, 5, 6, 7. We have a seven-sided polygon, and you will also given an array of values. And suppose the values are like this: 4, 1, 3, 2, 7, 6, 8. So the values are in clockwise order. So we can start assigning them like this: 4, 1, 3, 2, 7, 6, 8. Now you have to triangulate this polygon. That is, you have to divide the polygon into a set of triangles where the vertices of the triangle will be the vertices of this polygon. So suppose we can split this polygon into triangles. So if we have n sides, then we can get total n minus 2 triangles. So one such example is like this. Split it. And maybe like this. Yeah. So we have n equal to 7. So 7 minus 2 is 5. So we have total 5 triangles. And by doing this, we have the weight. So the weight is for this particular triangle, its weight is 1 into 3 into 2. And for this triangle, its weight is basically the product of the vertices. So it is 1 into 7 into 2. And for this triangle, it is 1 into 4 into 7 and so on. So for this split, the weight will be the total sum of all the triangles. And we can get a different sum by splitting the triangle differently. Maybe we can split it like this. If we do a split like this, here also we have 1, 2, 3, 4, 5 triangles, and this will have a different weight. So out of all possible splits, we have to return the minimum possible score that we can achieve. So let's look at the example. The first example has 1, 2, 3. So it's a 3-sided polygon, and the side vertices are 1, 2, and 3. So this is already a triangle, so we can't split it further. And the result will be 1 into 2 into 3, which is 6. Now if we look at the second input, we have a square, not a square, a 4-sided polygon. We have 3, then 7, 4, maybe we have 5. So for this, we have two choices. So the choice one is we can split it like this. So the triangle will be 3, 7, 4 and 3, 5, 4. So the 3, 7, 4 will be 3, 7, 4 plus 3, 4, 5 will give you 144. So splitting it this way will give a result of 144. And we also have a choice to split it this way. So if we split it this way, the sum will be 3 into 7 into 5 plus 4 into 5 into 7. And this split will give a result as 245. So the minimum of these both is 144. So we written 144. Now finally the third input, we have 1, then 3, then again 1, 4, and then 1, and finally 5. So we have a 6-sided polygon. This also has multiple ways you can split. So the minimum split is 1, 1, 3. So we have 1, 1, 3 and then 1, 1, 4. So this is 1, 1, 4. Next is 1, 1, 5. And finally we have 1 1 1. Okay, I think this is not the split. 1 1 and 1. Yeah. So if we do a split like this, then we have 1 1 3, this triangle. Then we have 1 1 4, which is this triangle. Then 1 1 5, which is this triangle. And finally 1 1 1, which is the middle triangle. So n is 6. So total triangles we formed is 6 minus 2, which is 4. And for that, the sum will be 13. And this is the least possible split. So we return 13. Now let's go over the approach. In this example, let's see example 3. We have the polygon of sides 6. And like these are the indices 0, 1, 2, 3, 4, 5. And I've also written the values. Now suppose we have split this polygon. We have randomly picked a side and we have taken a triangle. So by doing this triangle, we get a weight of 1 into 4 into 5. So we have weight 20 for this triangle. So after splitting this polygon with a triangle, we have the entire polygon is being split into two other parts. So let me draw the parts. So the first part is this small triangle, which is like this, index 5, 4, and 3. And we have another polygon which is split like this. From index 0 to 3. Now, since I have split this entire polygon by making this triangle, its weight will be 20. And after the weight, we can also add the answer of this polygon and the answer of this polygon. So this will give you the total answer of the original polygon of side 6. So this triangle will have the answer as 5 into 4 into 3, which is 60. Now this polygon will again be split. So like how we split the polygon initially, this polygon will also be split. Like first we will draw a triangle, and then this will be split into two other parts. First part is this, and the second part is it's not present. So the sum will be 0. So what we can think of is once we split the problem is being split into smaller sub-problems. So suppose we want to find the answer from index 0 to index 6. We want to find the answer if we triangulate this whole polygon. Now we have choices to make a split at any of this index. So if we make a split at index 1, then it becomes like this: 0, 1, and 5. This is 5. The index is 1 based, 0 based. So indexes start from 0 and ends at 5. So for the entire polygon, if we made a split at index 1, we will have this triangle formed. And this triangle's length, this triangle's contribution will be 1 into 3 into 5, which is 15. Now once this is split, we have the another polygon, which is from 1 to 5. So when we split it, we got the sum as 15. And after splitting it, we just need to calculate the answer for the remaining part. And once we get the answer, we add it to 15 and then return it. So this is the answer when we do the split at 1. So we also have a choice to make a split at 2. So let me just make it 5. Now if we make a split at 2, the convex polygon will split as follows. So this is a triangle formed, and the contribution of this triangle will be 1 into 1 into 5, which is 5. After splitting it, we have two other sub-problems. The first sub-problem is from index 0 to index 2. and the other subproblem is this bottom part, which is from index 2 to index 5. So if we split at index 2, the answer will be this 5 plus answer of this plus answer of this. And similarly, let's again take another example, another split. Let's say we are splitting at 3. So the triangle will be formed as follows. And the triangle's contribution will be 1 into 4 into 5, which is 20. After 20, we have the convex polygon split into two other parts. One is from index 0 to index 3, and the other part is index 3 to index 5. So when we split it at index 3, our value will be 20 plus answer of 0 to 3 plus answer of 3 to 15. So we can notice that we just need to check for all possible splits. So split at 1, split at 2, split at 3, split at 4. So we can split at all these possible choices, and amongst all these 4, whatever split option will give us the least answer, that will be our answer. So to just generalize this, we can say that if we have our polygon from S to E, then we can split this polygon at any point I. This I will be between S plus 1 to E minus 1. So when we do the split, that means our answer will be this values of S into values of I into values of E. This is because we have just formed a triangle with these 3 vertices. So this is the contribution. So after splitting this, then we will again have, since we have S plus S to E and we are splitting at I, then we need to find the answer from S to I, and also we need to find the answer from I to E. So for any given particular range S to I, this is how we can split it, and this I ranges from S plus 1 to E minus 1, and overall whichever is the least, and that will be the final answer. So we can see that we have repeating subproblems. So to avoid that, we can just store the answer for any particular S and E in a DP array to avoid preprocessing, to avoid duplications. So we can take a 2D DP. So it will be like n rows, n columns, and DP of S E will store the answer of the triangulation of the polygon from index S to index E. Now coming to the code, let's first try the brute force approach. So we have n equal to values.length. After this, we just need to return triangle of from 0 to n minus 1. So we need the triangulation from index 0 to index n minus 1. So we'll just create another function which will recursively calculate this triangulation. And triangle. So parameters will be start, int, end. Also we need to pass the values array. Now once we have start and end, like we discussed, we need to iterate from start plus 1 and I less than end I plus plus. So this is where we are making the split. So if we make the split at I, our triangle contribution will be values of S into values of I into values of E. So once we have made the split, we need to call this triangle function for the 2 other parts. So that is from triangle of S comma I and triangle of I comma E. So this is what our value is, and we need to minimize this value over all possible I. So for that, we can just take a variable, and min equal to, initially let's take it integer at max value, since we are trying to minimize it. And let's say min equal to math dot min, this min comma the new value which we have just calculated. So once this for loop is done, we have calculated the minimum value over all possible splits. So we just return the min. And one more, the base case here is for a triangle, the range will be from 0, 1, and 2. So if we have the range anywhere less than this, so that means if E minus S is less than 2, that means we can't form any triangle, then we just return 0. If we have only 2 sides, then we can't form a triangle. So this is going to be our base case. So let me just test it. Integer dot max. Yeah, it works. But if I try to submit, this will result in TLE, because this loop will, this triangle recursion will calculate duplicates. So to avoid the duplications, we are using a DP table, int DP new n rows and columns. And let's pre-fill the DP table first. Arrays dot fill DP of I. We are pre-filling the values with -1. And let's also pass DP. Int DP. And wherever we are calling the function, we need to pass DP as well. Yeah, once the base case is done, let's also check if we already calculated the value for the particular S and E. So if DP of S and E is not equal to -1, that means we have calculated it. So we just need to return from the DP table, DP of S and E. And if we didn't calculate it, then we will calculate it now. And before returning, we will just store it. DP of S E equal to min. Now let me submit. Yeah, and now it works. Finally, let's do the time and space complexity analysis. For the time complexity, we are doing a recursion. Like first we are pre-filling the value, the DP array, which will be n square. After that, we are doing a recursive function, but in this recursive function, the number of times it iterate is bound on the S and D values. This will only run for all possible values of S and all possible values of E. So that is basically the size of the DP table. So this triangle will run order of n square. And coming to the space complexity, we have initialized a DP table, so that will contribute to a space complexity of order of n square. And I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.